Who's my favorite student? I am, Mr. Do-It. No, Fahim, you're not. Figure it out. It's going to be Anne. It says, be sure to report to the correct number of sig figs. I need to remove those. I used to, until about 5 years ago, make you do sig figs the entire year. And then I thought, all I'm doing is just hammering people for a concept that doesn't really make... Anyways, I decided I'll go to 2 or 3 sig figs and just call it that. Number 1 says this, for 2 marks, I guess even though it's multiple choice, if you get it right, you'll get 2. If you get it wrong, you get squadoosh. A 5 kilogram object is pulled at a constant speed. There's a key phrase by a horizontal 12 Newton force. What's the coefficient of friction? This is a job for a free body diagram. Although they gave me a picture, so Kara, I'm gonna just label the picture. I have gravity down, normal force up. Pretty sure normal force here is the same size as gravity. The mystery force coming from off the page we've often called F applied. Friction. Should friction be bigger, smaller, or the same size as F applied? How do you know same size this time? Constant speed. In fact, really, I can say this. F applied equals friction. 12 equals mu times the normal force. I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force, mg. I can say 12 equals mu mg. And now to get the mu by itself, I'll divide by mg. I think it's going to end up being 12 divided by 5 times 9.8. Is it A? It's almost 12 divided by 48. 12 divided by 48 would be 0.25, so I figured it's going to be close to 0.25. 2 marks, all or nothing. Ooh, air resistance, like our thought puzzle today. A freely falling object falling downwards. If it's moving downwards, which way is air resistance pointing? Upwards. What if it was moving upwards? Which way would air resistance be pointing? Downwards. And accelerating downwards. Gravity's winning. That's enough for me to do my free body diagram. Gravity. What if it had said that it was moving downwards but slowing down? Which arrow would be bigger? Go on. Okay. I'm trying to think of how many ways I can muck up this question, and if I'll give you a different version on the test. Ooh, what if we were moving on the way up? I would have gravity down and F air pointing down. 2 winners, no loser. But here, I'm pretty sure I'm going to have mg minus F air equals ma. From this equation, I can either give you the acceleration and say find F air, or I can give you F air and say find the acceleration. It looks like I've done the second version, so it's going to be divide by m, Scott's theorem. It's going to be 0.62 times 9.8 minus 1.4. Do I need to multiply that 1.4 times 9.8? When do I need to multiply something by 9.8 to change it into newtons if it's a mass in kilograms and I want to use its equivalent force? Divided by 0.62. A is going to be, I don't know, bracket 0.62 times 9.8 minus 1.4, close bracket, divided by 0.62. Did you all get 7.54? Oh, I knew it was going to be less than 9.8 because if we were in a vacuum, the fastest we can accelerate is 9.8. So I had a bit of a built-in error check here. Is it 7.54? Is that right? If you got that, 1.5 out of 2. If you added the meters per second squared, 2 out of 2. If you got that, 2 out of 2. Otherwise, I would probably go something like this. Half mark if I saw the free body diagram. Half mark if I saw the winner minus loser equation. Half mark for getting the A by itself. And a half mark for the answer. The what force? The net force. The what force? The net force. So the first thing I wrote is that. And I said, I'm going to spend some time finding A. It looks like VI is 0, VF is 15, D is 85. I've seen this question style before. A is going to be VF squared minus VI squared all over 2D. It's going to be 15 squared. I guess I don't need to type the minus 0 squared. Divided by 2 times 85. I get 1.323. I'm going to write 1.32, but I'm going to store this on my calculator. I'm going to walk it over to here. F equals 1200 times my answer button. You get 1,588. I'll go to 3 sig figs, 1,590 newtons. If you got that, 2 out of 2. Otherwise, I would probably give you a half mark if you had written F equals MA. I would give you a half mark if somewhere I saw that you had tried to find A, half mark for finding A, and then a half mark for the answer. A block initially at rest is pulled across blah, blah, blah. What is the final speed? Oh. Wants me to find VF. Well, VI is 0. D is 16. What else do I need if I want to find VF? Well, time would work, or acceleration. I don't think I can find time from the data that they gave me. I think I can find acceleration. I might be able to find time, but I think I'm going to find acceleration. So I'm going to say to myself, self, that's a blank I need to fill in. How? This is a job for a free body diagram. Gravity down, normal force up. We have F applied. We have some friction. Who's winning? F applied. Who's losing? Friction. What's that going to equal? MA. And I'd like to find A. I'm going to use Scott's theorem. I'm going to get A equals F applied minus mu times the normal force all over M. I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force, little mg. So I can find A. A is going to be 56 minus 0.24 times 12 times 9.8 all over 12. 56 minus 0.24 times 12 times 9.8 all over 12. Did y'all get an acceleration of 2.314 and then the sixes start to repeat? People nodding. So I'm going to write 2.31, but I'm going to use my answer button and walk it over to here. I think I'm going to use VF squared equals VI squared plus 2AD. Although since VI is 0, I can get rid of that. And how do I get rid of a squared? Square root. So I think I'm going to get VF equals the square root of 2 times, I'm going to write 2.31, but I'm going to use my answer button, times 16. 2 times answer button times 16, square root of that, 8.6. How do I know I don't want the negative answer in this question? Remember, sometimes we have to take the negative velocity. Well, looking at my picture, I've got it accelerating to the right. I'll call to the right forwards, and yeah. 8.61 meters per second. If you got that, 3 out of 3. Otherwise, I would probably do something like this. Half mark if I saw that, half mark for that, half mark for the numbers, half mark for finding A, half mark if I saw that, half mark for the answer. Probably. Then I would turn the page over. Someone was asking me, and you're right. I should have signed that diagram. It's such a work of art. My bad. I will next time. Okay. A cross-country skier is moving across packed snow. The coefficient of friction between the snow and the skis is 0.11. That's low. Oh no, snow is pretty slippery. I'm okay with that. That's why skiing doesn't work on a sidewalk. What's the difference between skiing on the sidewalk and skiing on snow? Mu. Everything else is the same. You still got the same poles, same skis, same gear. It's the coefficient of friction. The skier can exert 110 newtons of force through her ski poles. Now, this is a bit complicated. I had somebody ask me this last day. They said, Mr. Dueck, you push backwards with your ski poles. Yeah, it's not your ski poles that make you go forward. This is very similar, Mallory, to when you're canoeing. You pull backwards on the water. Forces come in. The water is what pushes you forwards. You push backwards on the snow. The snow is what pushes you forwards. Here's what I know. In my free body diagram, I know, I'm going to call it an F applied. I know there's 110 newtons forwards. F snow, you can call it that. If you called it F pole, I wouldn't take it marks off, but technically you are pushing backwards with the poles. But I didn't do this properly. I should have said get the obvious one. I should have said we're not sinking into the ground like quicksand. And now I can say friction. I'm betting friction is shorter because snow. What's her acceleration? Well, let's see. I can go winner minus loser equals ma. Scott's theorem. So, A is going to be 110 minus mu times the normal force all over 47. I don't know the normal force. Oh, but look. I know the force is the same size as the normal force, mg. So I think I can say A equals 110 minus 0.11 times 47 times 9.8 all over 47. Let's see. 110 minus 0.11 times 47 times 9.8 divided by 47. Got a typo? F applied minus mu times the normal force. You get 1.26 meters per second squared. If you got that, 3 out of 3. Otherwise, I would probably go something like this. 1 mark if I saw that. 1 mark if I saw that. Half mark for the numbers, and a half mark for the answer. I had somebody in my other block say, Mr. Dueck, this isn't quite right because when you're cross-country skiing, you don't accelerate at a steady rate. As soon as you finish pushing, you start to slow down, and then you push and you speed up, and then as soon as you're lifting your poles up, you're slowing it. You kind of speed up, slow down, speed up, and they're right. Really, we're finding an average acceleration because that's the best we can do without calculus. Good point. Steady speed. This is a job for a free body. I should underline that. That's important. Free body diagram. Gravity down. Normal force up. F applied. And I think that's what they're asking me to find. Why would that be wrong? Or, why would this be wrong? I mean, even if you draw a sloppy free body diagram, as long as you get the equation right, you'll be okay, but I'm going to be fussy and say steady speed means that. So really what I can say instead of winner minus loser equals MA, it's a tie. I can just say, you know what? F applied equals friction. F applied equals mu times the normal force. I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. I can say F applied is mu mg. F applied is going to be, hey, what's mu? I don't know. What's mu with you? 0.32, sorry, times M times G. And I get 62.7? Newtons. If you got that right, 3 out of 3. Otherwise, I would give 1 mark for that, 1 mark for that, half mark for the numbers, and a half mark for the answer. Can you give yourself, if you have finished the quiz, a score out of 15, please?